All right, so I do want to give a shout out to Matt Nazarenko, wherever he is. So he helped me out with this. There he is. Helped me out with this this presentation. So let's get going. So I'm just going to start right away with how we measure slump. Okay, so you saw an example of an internal probe that rotates through the concrete, and the force on it gives you an indication of the slump. So what we do, and Denis introduced this concept already, but what we're doing here is we're measuring the amount of energy or torque it takes to rotate the drum. All right, so in a sense, it's a more global measurement versus a local measurement. And to what Denis was talking about before, you do a lot of interesting things when you start pairing this with other information. So here you have slump, like we talked about, as a function of both the hydraulic pressure and then how fast you're turning. So this is very similar to a rheometer case. So other factors that affect the measurement accuracy, so it's your mix proportions, your drum speed, your truck type, load size, and we talked about the tester precision. So you can look at this as a negative in terms of, oh, there must be a lot of calibration that's involved with this. We figured out, based on how much data that we've generated over the time, that once you start to predict a very accurate measurement with this system, you can kind of backtrack and start to look at these other things, like different mix proportions, viscosity, thixotropy. So you can kind of turn the problem on its head and start to tease out a lot of new things. This system is on over 3,000 trucks. So since its inception, we've put about 55 million cubic yards through this. So this is not a toy that we have in lab. This is something that gets used day in and day out by several large companies. So last week we put out 400,000 cubic, just last week, 400,000 cubic yards. That's a tenth of the Hoover Dam down at the bottom. So we had a gentleman ask about accuracy, and this is very similar to what Denis can show as well. We've had internal validation, so what you see on your left are basically slumps that we've measured, actual slump measurements versus a calibrated truck. This is 386 separate comparisons over 4 different customers with all their different mix designs. I think the big thing here is that showing basically the one-to-one line is line of equality, and then you have your predicted slump on the X, or predicted slump on your Y, actual on your X. This was done over a wide range of concrete mixes. So you see here a large, wide variation. We've also had external validation with this. So Kamal Kayat and Nicholas have looked at this. They've done some studies on this and have published this in a few articles. So that's available as well. Just to talk about how we communicate this, and Denis has also covered this, we need to compare this back to ASTM precision. Because basically it's almost impossible to say that we're more accurate than the actual test measurement, because you can't really prove that. So yeah, but things in terms of what Denis said, in terms of the coefficient of variation, those kind of things are things that we can tease out. But what we like to tell the people who use these systems is they're as accurate as what you would expect for ASTM. These are the truck components for the Verify system. So what we have here, we have our hydraulic pressure sensors, which are installed here. On the drum itself, we have a wireless drum sensor, which gives you both drum speed and also temperature. We also, in addition, and this is where the management part comes on, we have a fluid addition system that's integrated with the slump measurement so that we can make additions automatically, either with water or admix, to adjust your slump. All right, and I'll get into that later on. So you have a box here basically that has your integrated admixture tank, all the flow valves and meters. You have an external display, and then just like Denis, also have a processor, GPS. We can track the truck when it's going to get a cup of coffee and other things like that. The driver, so we have a driver interface, which helps them understand a little bit about any actions that they need to take. All right, so just an example of some of the data that comes out through this. So we have all these reports that basically give you an idea of what happened for that truckload. All right, And so you have all the, so for example, your slump, you have the black, which is your slump target. And this is fully customizable by the producer. So in this case, you had a slump target of 5 inches. And then once you got to the site, for example, maybe you want to switch it to 7 inches. You can think of, if you're carrying SEC, obviously you can't go to very high slump because it might spill out the back. So this is kind of an analogous situation. So what the system does is that you have a target, and this one came out at 2 inches out of the plant. And so what you normally would do is you bring it to the slump rack, and then you have the guy kind of eyeball and put in the water, and then you get your slump. That may or may not get you to the right slump. But with this constant measurement of your slump and connecting this with your fluid additions, you can see that the water was automatically added, automatically brought up to your 5-inch slump, and then you were out your way. So you don't have to wait your truck at the slump rack. You can just leave the plant right away, and then as long as you have enough transit time, by the time you get to the job site, you have reached your slump at the right target. So for this case, we basically have a water limit. So this is adjustable by the producer. Once it gets to this limit, then the producer can set rules around this. Either you can't add any more water or that water has to get documented, but either way you can see what was done. For this case, once it got to a certain point and the slump target was changed, it switched over from water to Admix, and then you can maintain your slump in this fashion. Drum speed, you can get an idea of this. So just as Brad was talking about, you really want, it's a very large safety issue driving down the road at elevated drum speeds. We track total revolutions. This is very important, especially in some specifications. And then also the temperature of the load. All right, so you kind of get an idea that we're able to monitor, measure, and manage the concrete, which again is taking the concrete driver out of the equation. And it's also helping the batch person QC so that they don't have to make so many adjustments. As long as they get the slump 2 or 3 or 4 inches, the rest of the management is taken care of by the truck. Just like Denis talked about, there's GPS, and so you can track all of these trucks, what state they're in, whether they're driving to or from a site, whether they're loading, whether they're discharging. And so that helps, obviously, with your planning. And all of this is uploaded to the cloud. So we say anywhere every 30 seconds, something from the truck is getting uploaded to the cloud. So you think about that, over 3,000 trucks, all of the trucks every week. It's a lot of data that we look at. The measurement, so we have the slump measurement, and then of course the management, which I just talked about. So I'm going to go through just a couple of just interesting things that you're able to do with a lot of this combined data. This first example is a 4-inch slump, 100 millimeter slump mix design. And the data that we have here, this is 11,000 loads. All right? So we took loads that were similar either in their mix design, and we wanted to see how the slump progressed. When it left the plant, what was the slump? When it arrived at the site, after the site, what happens? And remember, because all of this gets documented, right? We can roll this all up into different reports. So when you see this, these are histograms, and then this is for basically when you get it out of the plant. So you can see that there's a large amount of, actually this is when you get to the site. So this is all of the loads, and some of the loads we say the producer might want to be managed. Some of the loads maybe they don't want to be managed. So that's all up to the producer. And there are various reasons you would want to do one or the other. This first histogram has all of them combined. All right, so all of your managed, verify managed, and unmanaged loads. So sometimes if you batch too high, let's say, and this is a relative, this is the relative slump compared to your target. So you can see the vast majority of mixes of loads were batched wet, right? And the other thing to kind of notice here is there's not, or there's a significant amount of data that's over 2 inches, right? So just like Brad was saying, people are adding water all the time. It's not just some, once in a while kind of thing. Most of the time it's not a big deal, but if it is, it's usually a really big deal. So you can see that a lot of times the producer will add too much water. This is in the batch stage. So obviously Verify is not going to suck water out of the concrete. It can only add, so it's not going to do anything. So you're relying on slump loss to get you to the right slump. There are other times when you're below, but there are some times you need to deliver maybe 10 minutes away from the plant. Sometimes it's a little bit too short of a time to add and get your water in properly. So those are these guys over here. Now if you strip out everything except the Verify managed loads, so those that the system touched, that's what you get here. Right? So visually you can see the variability just tighten right up. And so now the interesting thing is once they're at the site, this is once you get to the site, arrive site, right on target, great histogram. As soon as you're there, somebody adds water. Now, 73% of your loads are now overwatered. All right, so this is kind of a behavior thing, and once you start to look at this this is a significant amount of loads, you have a story to tell. You have a story to make the concrete better, to talk with your contractor, to talk with the ready mix person, to kind of have that conversation now. All right, now that you can actually see, because this is not insignificant. This is a very, very large amount of mixes that, this only goes up to 5 inches. So I had to put 5 inches on the histogram. I mean, that says something, right? So now if we look at here, this last one is just comparing basically those managed versus those not managed. And you can go and make improvements on all of this. That's the story that we kind of want to give. Switching gears a little bit, and Denis talked about this as well. So we have these sneak water additions where water comes in from some unknown source. So if you have, obviously we also have flow meters on all the trucks, so we can, anything that's added through the truck system, we understand. But there are times that someone does take a fire hose, someone does take a hose to the truck, and you can kind of see that, right? And so the system can learn how long it takes to mix in water, what 2 gallons of water looks like for this particular mix design, and that gives you a good idea to see what happens in all these. And I was very happy to hear stories that you've talked about where you really can get into some liability issues, but since everything's documented, those issues go away for the ready mix producer, right? And also, again, with the contractor, we can kind of change some of these behaviors. All right, so one of the last technical slides I just want to talk on is the increased admixture efficiency. So a lot of the chemical producers out there, typically for admixtures like polycarboxylate supers, it's better to have a delay before you add the admix. When you think about how you batch in a plant, it usually goes with the tail water, right? And so that's a delay of 30 seconds or something like that. With Verify, since you're able to add on the truck, you can delay for 30 minutes if you wanted to. All right, and so we've done a bunch of studies to see how this affects the efficiency of the polymers that we use. So this is just one histogram that shows we combined 100 plus loads that had similar mixes. And so what we said, we worked with the producers to say, hey, can we strip out all of the admix that we're adding at the plant? Can we add all of that later on? And so we can compare it to what they normally use compared to what's added through Verify. And so what this is a histogram of is basically the percent reduction in admixture that you use if you delay it through an onboard system, right? So you can see that averages around 15, so 10 to 20% admixture efficiency increase you can think of, you can gain through the system just by delaying it to when you need to add it. So if you have that tool, I mean, the producer is free to use that as they wish. They can either reduce their admix, or in some cases, if the mix design can handle it, you can keep the admix in there, decrease the water, and then even decrease your cement to get some cement savings. All right, so just to kind of wrap up, there are a lot of production challenges at the plant, on the road, and at the job site. And so you can see how a tracking system like this, and Denise, gives you that visibility on what's going on. And that really allows the producer and also the contractor down the line to kind of optimize their productivity. I think the main takeaway from a lot of this is that you're giving time back to the QC person. So I'm not going to say that concrete needs these systems because we've been making concrete for 80, 90 years. But what this does is it gives us a tool to kind of really optimize and do kind of some of the fun stuff that we want to do in terms of the mix design, tweaking, and those kind of things. Denny and Brad also talked about the productivity management in terms of just getting trucks out the door quicker, being able to line up your trucks properly. And then also once it's at the job site, if the contractor knows the slump is right on, they can pull that truck out of line. And we've had stories of this. They'll pull the truck out of line and say, hey, your slump is already is ready. Let's go and add you to the pump. Also, the mix over engineering due to the variability. So being able to manage while you're going down the road really decreases the variability in the water contents and also the slumps. So this adds value all through the chain. So I talked about most of these things. The other thing too is the reduced back charges and rejected loads. So that's a big thing. We talked about temperature today. We talked about slump. Those are two big reasons you get rejected. Talk about having the truck too old, 90 minutes. It's not an issue anymore, but revs, sometimes that's in the specs. Those things are all documented, so really minimizes these, really the risk for the ready-mix producer. All right, and with that, I'll take any questions. Thank you. Yes, sir.
As a concrete producer, would you have any objection for this to become part of the spec, provided we share that data in real time with the owner?
With the owner? Yeah, I don't, so from a GCP perspective, the data is our customers, the ready-mix firm, right?
Yeah.
So it's up to them to kind of figure out how they want to use that data. I think it's, and Brad has talked, hey, if it's gonna make the concrete better, let's kind of do that. If it's to make the operations better and all those kind of things, that's something that that we should do. I think it's a great question to open in terms of, I mean, we all have concerns about privacy, security around our data, and those are kinds of some of the things that we need to have discussions on. Yes, sir.
Can you go back to slide 7?
Maybe. I have numbers on here.
Yes. So just to clarify, the top left is loads that were all measured but not necessarily managed, right?
I think this one has all of them. Is that correct?
So it's top left is all loads. So everything that's verified is measured. And so you're showing that the slump's highly variable.
Yeah. So Terry, that's an excellent point. So if I showed this histogram of before the system was installed and you're measuring, I mean, it's going to kind of look like, it's going to look more like this one.
Yeah.
That's it. That's an excellent point.
And then the top right, only managed.
Only managed.
So that's why you've tightened up that.
Yeah.
And then the bottom left, the contractor has added a whole bunch of water and increased the slumps.
Yeah. So it's very interesting. So if there was no measurement, it would look like this. And then you add the ability to adjust in real time. And then unfortunately, it goes back to this level. So that's something that we work with.
Great presentation. We in the San Francisco Bay Area have been using the Verify for years. And they work much better than they did at the beginning. But why are the tanks usually empty?
That's up to the producer.
Really?
That's up to some of the decisions that
They'll sell it as needed then,
Yeah.
as they determine.
Because don't forget, I mean, there's all kinds of ways you can add the admix. I mean, you could, some people like to manage, get up to your 8 and then manage with water. There's, you reach your water limit, so people have different ways they can use. Yes.
With clients who might require like batch weights on a ticket, and obviously we're in transit adding high
Yep.
range, maybe
Yes.
retarder,
Yes.
maybe what, like,
Yes.
so how do you,
All of that gets documented.
but at what point? So
Uh,
like, if the driver has a ticket from the batch.
So in real time, so they'll have a record of this afterwards. And so that's where the max water comes in, because you basically, normally you would set max water not to exceed that, right? And so that'll be, yes. And
Yeah,
max-
so we have an application that's available, and it'll show real time how much water or admixture went in, and this is available for an inspector. So when the truck arrives, it's geolocated within 10 meters of where their phone is, so they can only see what's right next to them. So they, instead of walking up to the truck, they can just say, okay, this had this much water and this much admixture, and write it on that ticket with the batch weight.
Gotcha.
You said you are able to add some admixtures on the road, but do you have like a routine to ensure complete homogeneity? Because you are not always able to mix at a high RPM on the
Per
road.
ASTM, usually to make any additions, once, after that addition, you have to have a certain amount of mixing.
Yes,
rev. So
so-
once you get to the site,
Okay.
yes, you'll need to ramp it up, make sure you do your res.
So sometimes the admixtures is added on the road, but it waits until on site too.
The interesting thing about that is, basically, the amount of revs is what's important to mix something, not the time.